be performing factoring of polynomials in this video. Let's start from difference of two squares. So if you have two squares, a squared minus b squared here, we can factor it out as a minus b and a plus b. In this problem, we need to express these binomials into squares. So here it's already square. It can be written as x squared minus 36 can be written into square, which is 6 times 6 or 6 squared. So this is our a. Our a is x and our b is 6. So we can now express it into this factor, which is a minus b. That is x minus 6 and x plus 6. Here, number 2, we can let's express this first into squares. So 4 can be expressed as 2 squared, b squared. 25 can be expressed as 5 squared. Now we can single out the square here, can be written as 2b squared minus 5 squared. Hence our a is 2p and our b is 5. And we can now write this as a minus b, which is 2p minus 5, and then 2p plus 5. For the third question, again, we express this as squares. That's 5 squared and p squared minus 3 squared and q squared for the square. Okay, the power of the loss of exponents. And then we can single out the exponents. This is 5p squared minus 3q squared squared. And this is our a and this is our b. So we have a minus b, that is 5p minus 3q squared times a plus b, which is 5p plus 3q squared. Next, let's move to another type of factoring. Factoring common factors. This is the formula. If you have common factor for each term, then you can take it out and you can form these two factors here. Now let's try this question number 1. See, 6 is common, so you can factor it out. We factor the 6 already here, so a will stay. We factor the 6 in 24, so 4 will stay because 24 is 6 times 4. And you can check your answer if you return it back. 6 times a. 6 times a is 6a, and 6 times 4 is 24. So this is the factor. Now let's go to this one. The common is 3 for 6 and 3. So you can factor out the 3. And then the common of our x coefficients here is x squared, the smallest exponent. So that is x squared. Now we factor out the 3 already from 6. So 2 will stay there. And x2 squared will stay. And then this is 3. We factor it out. That's x. And then we factor out 3x squared, so only 1 will remain. Now, if you want to check if your factors are correct, you can multiply it back and distribute. So 3x squared, apply the loss of exponents for product rule. And we have 3 times 3 is 6. Then add the exponents, that's x to the 4th. And this is, remember, this is 1 here, so that's 3x. The exponent here is 1, so 3x cubed. And then multiply this 1, so that results 3x squared. Next, here, the common of our numerical coefficient is 4. And then for x is x squared, factor it out. And then for y is y cubed, the smallest exponent. So we factored out the 4 already. This is 4. factor out x squared, so that's only 1 left. Here we factor out the y cubed, so it's y left. Factor out the 4, factor out the x squared, factor out the y cubed, so only 1 left. If you multiply it back, that's 4 times 4 is 16. That's x squared, and y cubed times y, that exponent here is 1. So that's y to the 4th. If you multiply this one here to negative 1, that gives you negative 4x squared y cubed. Next, let's go to another types of factoring. You can look at the formula here. You have this one, that one. These are the important parts because this will determine the middle term of the polynomial to give us these factors. Now, this can be demonstrated using the FOIL method. Okay, I'll show you for this number 1 here. The coefficient of our r squared is 1. You have to look at the factors of 1, which is 1 times 1. It's nothing there. Now, 4, the factor of 4, you have to look at the coefficient of your first and the last only of the polynomial. So, here the factor of 4, you can have 2 times 2 or 4 times 1. Now, we have to select carefully so that we will have the middle term 3r. So what we're going to do here, we'll do the trial and error using the FOIL. Now the first term should be r times r, because when you multiply that, that's the f of the FOIL, that's r squared, and then you go to this term. Okay, so say we select here a middle term is 3r, so the only factors here that can result to 3 is 4 times 1. Okay, let's check it out. 4 and 1. And if we multiply that, 1 times 4 is 4, gives us the third term. And this is the L of the FOIL. Now next is the inner of the FOIL, the I of the FOIL. So 1 times r is 1r. And then 4 times r is 4r. Now we have to make sure that if we add this, the result will be the middle term, which is 3r. That means to get this result plus 3r, that means our 4r must be positive and minus 1r is negative. And the arrangement of our sign here in the factor, to make positive 4r, this must be positive 4r. And to make negative 1r, this must be minus 1r. So therefore the factor is r minus 1 and r plus 4. Now let's go to this one. Now we have the first term and the last term here. And the factor of 2 is 2 times 1, nothing else. The factor of 6 can be 3 times 2 or 6 times 1. Okay, so let's do the trial and error. Let's write down the 2n here and the n here. So if we multiply the f of our FOIL, we have 2n squared. Okay, that gives us the first term. And which factor here of our 6 can result to the middle, which is 1n. Let's try 3 and 2. Okay, I will put my 2 here and my 3 here, so that when I multiply, by the way, the third term, that is 6. Okay, it gives us 6 here. Now here there's a chance it can be equal to 1, because if you take the inner, multiply the inner, that's 3n, and the outer is 4n. Okay, and then make sure that this will result to plus n, which is equal to the middle. And the only way to do that is this should be positive and it should be negative. 4n minus 3n is 1n. And to make this plus 4n, we put the addition here. Okay, plus 2 times 2n is plus 4n. This must be negative. Negative 3n. 3 times n is negative 3n. So this is the factor, which is 2n minus 3 and n plus 2. Okay, next for this one, we have 6. Factor 6 is 6 times 1 and 2 times 3. The factor of 20, okay, we have several for 20. 4 times 5, 10 times 2, 20 times 1. Okay, we'll do the trial and error here. I will pick, you need to look ahead of the problem so that you can minimize your trials. I will pick, say, 2k and 3k. All right, and then I will select probably 10. If I select 10, I put it here. If I select 10, put it here, I get a 30, and the 3 here, a 2 here, I get a 4. So 30 minus 4, I don't get a 23. So this is not a good choice. Let's pick a 4 and 5. So we'll pick 5. If I put 5 here, okay, and 4 here, I will have 8 and 15. That will result to 23. Okay, let's try this out. Okay, sorry, we have the k squared here. I will write it properly. I have 2k, then 5h. Sorry, this is h. 5h, then 3k, 4h. Okay, so the first is 6k squared, and the third term is 20h squared. Let's go to the inner. That is 15 hk, and then the outer, that is 8 hk. Okay, if we add this can result to 23, but let us look at the sign first. So the result should be negative 23 hk, and the only way to do that should be negative here and negative here, and that is true. True, because if we put negative and negative here and multiply this for our last, for L of the foil, negative 5h and negative times negative 4h will give us positive 20h squared. So therefore, the factor is 2k minus 5h times 3k minus 4h. Here we have sum of two cubes. Now this is the formula for sum of two cubes, a plus b cubed. And then the result is a plus b. But in the second factor, you have a squared minus, okay, you just square, you look at here, look at the factor here. That's a plus b. So you just square this, a squared, and then you multiply a times b, that's ab, but the sign here will be negative. And then next is you square the b squared. So that's how you remember the formula. Now here, if we can express this binomial into cubes, then we can use the formula. But 8 is 2 cubed x cubed plus 27 is 3 cubed. So therefore we can write this, you can single this out. That's 2 cubed plus 3 cubed. And this is already in this form, some cubes already. So where our a is 2x and our b is 3. Now we can now write this as a plus b, which is 2x plus 3. And then we we square this. We square this, or you can write it like this: square, then minus a plus b squared. Let's put our a and b here. So this is a squared here. That's 2x. This is our 2x, or a, and b is 3. And then this is b. All right. So this is now 4x squared. This is minus 6x plus 9. This is the factor. Now let's go here. Change color. Now we express this as cubes. This is 2 squared p, 2 cube and p cube plus 1 cube. Alright, so we can single this out. 2p cube plus 1 cube. Or we can write this as, continue here, our a is 2p and our b is 1. So that's 2p plus 1. And then we square this. That is 2p squared. Then multiply this. Since we use minus, multiply that. That's 1 times 2p plus square this one. That's 1 squared. Okay, and this is now 2p plus 1. That is 2 squared. That's 4. P squared, 1 times 2. That's 2p plus 1. So that's the factor. Next, here in the third problem, we express this as cubes. So this is 3 cubed and x cubed plus 125 is 5 cubed. Y to the 6 is y squared to the cube. Because when you apply the loss exponents, you multiply the exponents 3 times 2. It gives you 6. Now this is, we single out the cubes. This is 3x cubed plus 5y squared cubed. So this is our a, which is 3x, and our b is 5y squared. Now we can now express this into this formula, a plus b, which is 3x plus 5y squared. And then square this one, that's 3x squared minus product of this one, that's 3x and 5y squared. And then square this one, that's 5y squared. And finally we have 3x plus 5y squared. This is square of 3 is 9x squared. 3 times 5 is 15. X, y squared. Square of 5 is 25. Y to the 4th. Close bracket. Okay, next is the difference of two cubes. So the idea is the same, except that we'll be using the subtraction here because it's the difference, a minus b cubed, and then here the sign is negative as well, but we will be using positive to the second factor. So your a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. Okay, now again we express this as difference of two cubes. That's 2 cubed for a, x cubed minus 3 cubed, and single this out, 2x cubed minus 3 cubed. Our a is 2x and our b is 3. So we can now write this as a minus b, that is 2x minus 3, and then square over a, 2x squared. This time it's plus, okay, and then multiply our a, which is 2x, and b, which is 3, and then plus the square of our b, which is 3 squared, and let's now simplify it. We have 2x minus 3, and this is square of 2 is 4, x squared plus 3 times 2 is 6x, plus 3 squared is 9. Okay, this is not a factor. Let's move to number 2. Okay, let's express this as 2 cubed r cubed minus 5 cubed t cubed. Single it out. 2r cubed minus 5t cubed. Okay, we can continue here. Our a is 2r, our b is 5t. This is 2r minus 5t. Square of this, 2r squared. This time it's plus, multiply this 2r times 5t, and then square second term, that's 5t squared. Let's continue here. It's 2r minus 5t. Square of 2 is 4. Square of r is r squared. 2 times 5 is 10 rt, plus 5 squared is 25 t squared. Here in problem number 3, do the same. We express this as difference of 2 cubes. 27 is 3 cubed. H to the 9 is h to the 3 to the 3. And 8 is 2 cubed. K cubed is k to the 3. We can single it out by loss of exponents. This is 3 h cubed to the 3 to k to the 3. Here we already expressed it as difference of 2 cubes. We can now use the formula where our a is 3h cubed and b is 2k. This is now, we have 3h cubed minus the b, which is 2k, and then the second factor, the square of our a, this is our a, and this is our b. The square of our a is 3h to the third squared. That's minus, so it's plus for the formula here. And then the product of the two, we have 3h cubed times 2k, then square of our b plus 2k squared. Okay, we can now simplify this. We have 3h cubed minus 2k, and then we distribute the square. That's 3 squared is 9. Multiply the product at h to the 6 plus 3 times 2, that's 6 h cubed k plus square the 2, that's 4, square the k, that's k squared. The next one is applications of factoring. So here, this difference of 2 squares, so this can be written as x 16 is 4 squared. Okay, that's x squared. So we have difference of 2 squares. So that's x minus 4 and x plus 4 over, this one's common factor, so we can factor out 2 x plus 4 will be the remaining factor here, and we can cancel this out, and the result is x minus 4. Okay, no need for this. X minus 4 over 2. Okay, for this one, this is difference of two squares because 25 is 5 squared. So that is x minus 5 and x plus 5. And then this is 2 squared. So this can be, let's deal this one first. So common is 2. That's 2. 2 plus y. And then for this one, this is 2 minus y and 2 plus y. Then x minus 5. Okay, let's look at it. If we can factor, this is common. X minus 5 common. So we'll be left with x plus 5 and 2 minus y all over 2. For this one, again, difference of two squares. This is 2x squared minus 5 squared. So that can be factored out as 2x minus 5 and 2x plus 5. Common here is 3. Can factor out 3. We'll be left with x plus 6. And then let's divide. We take the reciprocal. The operation will become multiplication. And x squared minus 36 is x squared minus 6 squared. And that will be at the numerator already. So that's x minus 6 and x plus 6. Then for this one, the common is 3. Can factor out 3. That will be left with 2x plus 5. Gonna be 2x plus 5. So it's common. 2x plus 5. Common for x plus 6. So the remaining factors are 2x minus 5, x minus 6, all over 3. This is factoring by grouping. What we're going to do is we group this and these terms. So we'll have x cubed minus 2x squared plus 5x minus 10. Now we factor out the common of this group, which is x squared. It will be left with x, this term, and minus 2. If you return it back, that's x cubed and 2x squared. The common here is 5. We'll be left with x here and minus 2. If you return it back, that's 5x and minus 10. Now, notice that each term has common factor x minus 2. We can factor it out. X minus 2. So we'll be left with x squared here. And we'll be left with 5 there. If you return it back, you will get this term. Multiply it here, we'll get this term. So this is the factor. Let's go to this one. Okay, again, we group this and group that. So we'll have 6x cubed plus 3x squared plus 8x plus 4. Okay, now the common here is 3 for the number coefficient, and x squared is the smallest exponent, so we have 3x squared. We'll be left with 2 here and x, and we'll be left with 1 here. So when you return it back, that's 6x cubed plus 3x squared. The common here for the second group is 4. So we'll be left with 2x plus 1 here. And again, this is a common factor. We can take it out. So we'll have 2x plus 1 and 3x squared will stay there and plus 4 will stay there. You return it back, you will have this term. Over here, we will have that term. Okay, let's go to number 3. Let's group this again and this ones. So we'll write it first. We have 20 x squared plus 30x plus, that's negative 4xy minus 6y. Okay, we can factor out the common here, which is 10. And the smallest exponent is x to the 1. The remaining factor here will be 2x, and here plus 3. You return it back, that's 20x squared, 30x. The common here is negative 2 and y. So we'll have 2 and x here. Here we have plus 3. If you return it back, that's negative 4xy and negative 6y. Okay, now common of each term is 2x plus 3. We can take it out, which is 2x plus 3. And this one will, 10x will stay. That's 10x and 2y. We're not done yet. 10 and 2 has common factor, which is 2. So we can take it out. Here we have 2x plus 3. We factored out the 2 here, which is now this one. So this is 5x minus y. Okay, when you return it back, that's 10x minus 2y.